So the next question, you can see the question number 9, which is put up on the screen. The following reaction is known as. Which reaction is this? Look at this reaction. Ethyl alcohol is reacting with thionyl chloride in presence of pyridine, and with the formation of alkyl halide, that is ethyl chloride. When you use thionyl chloride, then that particular reaction is directly, we can call it as Darzin's reaction. In the Darzin's reaction, what happens? Ethyl alcohol is converted into ethyl chloride. So in presence of pyridine as a catalyst solvent, and also when it reacts with the thionyl chloride. So the correct option is option B. Option B is the correct option. It is Darzin's reaction. Question number 10. Decreasing order of reactivity of HX in the reaction. Which one is more preferable and which one is less preferable? Let's have a look. Let's take down the nucleophilic substitution reaction. SN reaction ROH. So question number 10. ROH reacts with what? It is given in the reaction HX to form RX plus H2O. So which is the fastest reactive with this one? So X, it is given HI is given, HBr is given, HCl is given, H fluor, hydrogen fluoride is given. Now you know that the charge of this, when it gets separated out, this will get the positive. When this bond gets separated out, this will get carbocation. With the carbocation, most reactive species, this is, of course, this is plus, this is minus, this is plus, this is minus, plus, minus, plus, minus. Now, in this, more reactive is iodine. Iodine is more reactive than Br minus, which is more reactive than chloride minus, which is more reactive than fluoride minus. Okay, this is when it forms a compound R, most rapidly it makes compound with Ri, so that the correct option is option A, which is Hi is more than Hbr, which is more than Hcl, which is more than Hf, and the correct option is option A, that is option A is the correct option for the question number 10. Iodide is more reactive than that of HF. Why? Because the bond strength is weak here, and here it is very strong. Which one? Bond strength. Bond strength is weak in this case and very strong here, so it is difficult to break, where it is easy to break, so that iodide comes out easily than that of HF. Okay, and the correct option is this one. So which is there in the option A. Next question, move on to the next slide. Look at the question. Question number 11. Question number 11. What is given? Let's understand now. What is given? C3H8 propane is reacting with chlorine gas in presence of sunlight. In presence of sunlight to form propyl chloride or chloropropane, and HCl get separated down. Is an example of which of the following types of reaction? What type of reaction is this? Is this substitution, elimination, addition, or rearrangement reaction? Which one is this? Now, when you take out this, when we write question number 11, question number 11, C3, that is 1, 2, 3, hydrogen, hydrogen, hydrogen. So this is a propane molecule reacting with what? It is reacting with chlorine gas in presence of HU, that is in presence of sunlight. When it reacts, what happens? it gets separated, free radical reaction takes place. So one of the hydrogen gets replaced, so by chlorine, and chlorine will occupy the position of hydrogen, and there is a formation of CH3, CH2, CH2, Cl, where removal of HCl. So this is simply a substitution reaction. In place of hydrogen, chlorine get itself substituted, so that the correct option is a substitution reaction. Option A is the correct option for the question number 11. So that is substitution reaction. It is not elimination, it is not addition, it is not rearrangement reaction. Okay, let's move on to the question number 12. Let's move on to the question number 12. Very important question. Very important. Question number 12 is very important. Most of the times, this question have been asked in many different types of competitive level examination. Very important question, I can say, question number 12. So, question number 12 comes like this. ROH reacting HX, the same nucleophilic substitution reaction, to form RX plus H2O. In the above reaction, the reactivity of different alcohol is, which one is more reactive alcohol? Tertiary, secondary, primary. Tertiary is less than secondary, which is less than primary. Tertiary is less than secondary, which is more than primary. Which is the correct option for this? Let's understand the correct concept of this question. Very important question. Please listen carefully. Question number 12. Question number 12. So question number 12. Now the reaction is ROX reacts with HX to form RX plus H2O. That is alkyl halide, from alcohol to halide. Alcohol to halides. Alkyl alcohol to alkyl halides. In this reaction, which follows nucleophilic substitution reaction. Now, when you take tertiary alcohol, see, this is CH3CH2OH. It is called as 1 degree alcohol. This is 1 degree alcohol. Why 1 degree? Because this is a functional group connected to only one carbon atom. So it is called as 1 degree alcohol. Now in this CH3, CH3, then I will write here HOH. All functional group connected to this carbon atom, which is connected to two carbon atoms. So it is 2nd degree alcohol. Now when you go for the tertiary alcohol, CH3, this is tertiary alcohol, 3 degree alcohol. Now the question is based on, in which factor? The question is based on inductive effect. For time being, this bond get breaks. When bond get break, this will get total negative charge, this will get positive charge. When it gets a positive charge, the same compound, when you break this bond, this will get negative charge, this will get positive charge. When you break this bond, this will get negative charge, this will get positive charge. When you break this bond, this will get negative charge, this will get positive charge. And when you see the concept here, this is, 1 degree carbocation. 1 degree carbocation. Even it is also stable according to inductive effect and also according to hyperconjugation. It is stable. But the thing is, there are 3 alpha hydrogen atoms. Here there are 6 alpha hydrogen atoms. And here there are 9 alpha hydrogen atoms. So the stability of carbocation depends on the number of hyperconjugates. Hyperconjugate is nothing but hydrogen connected to the next compound. I mean the next, this is called as 6 hydrogens, which is acidic hydrogen, and also it is called as hyperconjugates. And there are 3 hydrogens, generally it is called as alpha hydrogen atom. So according to all, this is more stable. Why? Because according to plus I effect, here 2 effects are acting, plus I effect and hyperconjugation. So in both this is more stable and it releases large number of electrons. So the positive charge, the big positive charge what it has, the positive charge here is, this will releases the electron through sigma bond, then positive charge becomes less, and this also releases still positive charge, it's very small positive charge, and this also releases the electron through this single bond or sigma bond. Positive charge becomes a point positive charge, very small positive charge, which cannot hold this bigger OH minus ion, so that OH minus ion will be go away, easily released, so that the attacking reagent like HX, where H plus X minus, and this X minus will attack this molecule easily because of the smaller charge. This will be completely replaced and it comes attacks this one. So that this is more fastest will be this one, tertiary carbobutyl carbocation or tertiary alcohols are fastest compared to primary alcohol. So the correct option is displayed on the board. So correct is tertiary is more than secondary, which is more than primary. No doubt option A is the correct option. Option A will be the correct option. So you understood, very important question, many times most favorite area. So nucleophilic SM reactions or nucleophilic substitution reactions. Definitely you will get question based on this type. At least one question you will get. So please do follow. Question number 13. You can see when ethyl alcohol reacts with potassium iodide. So potassium iodide here, one thing is missing, excess. You please write down excess. Excess, more. Reacts in presence of sodium carbonate. Yellow crystals of dash are formed. Which one is formed? Which is a yellow crystal? Which is a yellow crystal? There are possibility of forming all the compounds, but the only yellow crystal is CH3, which is iodoform. So you can see the reaction here. So this is given excess. This is excess amount of potassium iodide reacts with this. In presence of sodium carbonate, this is formed. This is called as triiodomethane, or it is simply iodoform. It is iodoform. Iodoform is formed. It is triiodomethane is formed, which is yellow crystalline solid. So this is the correct option. So option A is the correct option for the question number 13. Move on to the next slide. You can see that which is given, which of the following is obtained when chloral is boiled with sodium hydroxide. So chloral is nothing but CCl3, OH, CCl3, CHO reacts with sodium hydroxide. So it is to be boiled to form CHCl3 plus it forms CHCl3 plus HCOO, sodium formate. Okay, so which of the following is obtained when chloral is boiled with NaOH? First of all, you should know the formula of chloral, and the formula this is called as chloral. This particular is called as chloral, which is also called as bleaching powder. When bleaching powder is treated with sodium hydroxide, these two compounds are formed. This is definitely chloroform CHCO3. Then this is sodium formate. This is chloroform. This is sodium formate is formed. And just see where these compounds are there. HCOO is not there, but this compound is a CHCl3, and the correct option is given there. Option B. Look at option B is the correct option. Option B is the correct option. But this type of questions are very rare. Very rarely they will ask. But still you should know. Sometimes if they ask, you should ready to face this type of questions also. Next is again very important question. The question is given glucose reagent test. Glucose reagent test means what? It is the reagent used to distinguish between primary, secondary and tertiary alcohols. To know what type of alcohol, in order to understand primary, secondary and tertiary alcohol, we will go for the glucose reagent, and the glucose reagent is a mixture of anhydride zinc chloride and concentrated HCl. So it should be anhydrous zinc chloride and concentrated HCl, and option A is the correct option. So you have already studied this reagent in the online class for the boards. So the correct option is concentrated HCl and anhydrous zinc chloride. So option A is the correct option for the question number 15. So move on to the next question number 16. See question number 16. The Grignard reagent may be made up of reacting magnesium with water. It's a simple direct question, direct any-based question. First of all, what is Grignard reagent? Methyl magnesium iodide, or MgX. So this is called as Grignard. This is called as Grignard reagent. It has many more applications in the preparation of aldehydes, ketones. Okay, even in alcohols also it has many more applications. This is called as Grignard reagent, may be made up of reacting magnesium with magnesium. 4 options are given. So in option A, methylamine. Methylamine is CH3, NH2 is methylamine. Then diethyl ether. In the option given, C2H5O, C2H5. This is called as ethers. Functional group is 4. And ethyl iodide. C option given, ethyl iodide, that is C2H5I. And option D is ethyl alcohol, that is C2H5OH. We should get when magnesium reacts with what type of compound? Rx. So in out of this is considered as RNH2, RO, R dash. This is RI, this is ROH, and the correct option is this is called as Rx. Is an example for, and option C is the correct option, where when magnesium reacts with this compound, there is the formation of C2H5MgI. So this is REMGX, the compound, and the correct option is option B. B. Clear? Question number 70. Question number 70. You can see question number 70. Methyl benzoate reacts with phosphorus pentachloride to give. First, what is this ethyl benzoate? These many compounds are formed: ethyl chloride, benzoyl chloride, phosphorus oxychloride. Many different compounds are given. Let's find out which one is the correct option. Let's write the reaction. Ethyl benzoate. Ethyl benzoate, how it reacts? Question number 70. Ethyl benzoate. Now, ethyl benzoate. Benzoates are the esters. Benzoates are the esters. This is esters, ethyl benzoate. So, ethyl benzoate. Which is ester. Functional group of ester are COO RH. So this is ester. It reacts with PCl5, phosphorus pentachloride. Let's understand phosphorus pentachloride. Very special and very important. When phosphorus pentachloride, when you write the structure, phosphorus, chloride, chloride, chloride. This comes in a plane. On the plane. Okay? Above the plane and below the plane, there is one more chloride. One more chloride. This bond breaks easily because they are not on the plane, get separated in the parama. This gets separated out in the parama. Cl, Cl and PCl3. PCl. So, PCl5 breaks into Cl and Cl, two chloride radicals get generated, and directly first chloride I can write. Shall I write like this? Chloride and chloride. I will write something like this. So here what happens? So much gets separated out to form first compound C2H5Cl, and the second one will get separated out. So this oxygen here it breaks, here also it breaks. So this connects here, then form the second compound. This is benzoate C6H5, COCl, COCl, and only oxygen is kept connected with this one. So the final product form is POCl3 and C2H5Cl, C6H5COCl, POCl3. This compounds, okay, here it is. It has HCl. It is not the answer. So C2H5Cl, C6H5COCl plus POCl3, and the correct option is option B is the correct option. So option B is the correct option for the question number 70. Question number 70. Question number 18. On treatment with chlorine in presence of sunlight, that is HV, toluene gives the product. Which product it will give? It is not electrophilic substitution reaction. If it is not electrophilic substitution reaction, then these many compounds will not form. Only one compound is formed, that is benzyl chloride. So, if it reacts with in presence of other reagent like carbon disulfide or any other reagent like acetic acid and all, electrophilic substitution reactions takes place, but it is clearly given in presence of sunlight. In presence of sunlight, free radical reaction takes place. Let's write down first the formula of toluene. Okay, formula of toluene. So question number 18. Question number 18. Question number 18. toluene. Toluene is methyl benzene is called as toluene. CH3, that is, I can CH3 I can write R CH3 reacts with what? Reacts with chlorine. Reacts with chlorine in presence of H nu. In presence of H nu. Now what happens here? Electrophilic substitution reaction will not take place. Only free radical substitution takes place. So hydrogen will be eliminated and one chlorine will be connects here. This hydrogen connects with one more chlorine. So what happens? The compound obtained is like this. CHH2 Cl plus HCl. This is called as benzyl chloride. This is called as benzyl chloride. So the correct option is option D. Option D is the correct option for this. Question number. Move on to the question number 19. Read the question. What is given? Question is given something like this, like reaction of methyl chloride with sodium leads to. But one thing is here one more thing you add in presence of dry ether. In presence of dry ether. So which compound is formed? It is best example for the Woods reaction. So Woods reaction, here it is, reaction of ethyl chloride, C2H5Cl, when it reacts with sodium in presence of dry ether. So one thing is forget to type there, it is dry ether, in presence of dry ether. Now what compound is formed? It is Woods reaction. It is Woods reaction. Woods reaction. In the Woods reaction, you know that only sodium gets separated out in the form of 2 NaCl, and what is left? It is C2 or simply I can write like CH3, CH2, CH2, CH3, which is N-butane. That is N means normal chain, straight chain. N-butane is formed, and the correct option is option C. Option C is the correct option for this question. Butane, N-butane is formed. Question number 20. Question number 20. Phosgen is a common name for. Phosgen is a common name. So first of all, you should know the formula of phosgen. It is the phosgen is a highly poisonous, deadly dangerous compound obtained in the polyhalogen compounds. Okay, it is a type of gas coming out which is highly poisonous gas, and the formula of that gas is COCl2. That is question number 20. Phosgen is COCl2. COCl2 name is carbonyl chloride. The name of this compound is carbonyl chloride gas. Actually it is a gas. Carbonyl chloride gas, highly poisonous gas. Okay. Question number 21. Next is question number 21. Which is not present in Grignard reagent? Which is not present in Grignard reagent? Let's first of all write down the formula of Grignard reagent. Question number 21. Grignard reagent is MJX. This is alkyl group like methyl, ethyl, propyl, butyl. This is metal. This is either bromo, iron. Okay, but most of the case this compound will not be there. Either chloro, iodo are the most common compounds. Iodo is most common here. So this, which is not present in Grignard reagent, methyl group, it is there. Alkyl group is a methyl group. Alkyl group is a methyl group. It is there. Yes, it is there. Magnesium is also there. Halogen is also there. But COOH is not there. This is not there. So the correct option is option D. Option D, which is carboxylic acid is not present in the Grignard reagent, which is the false compound, which is not all comparable with the Grignard reagent. Next question. Question number 22. Given, actually it is a rare question. In fact, what is given? War gas. What is this given? War gas, which is also called as tear gas. Which is also called as tear gas. What time? When chloroform reacts with HONO2. HONO2, that is nitric acid. That is HNO3. When chloroform reacts with nitric acid, that is HNO3, the compound is formed. So the compound form will be CCl3 plus NO2. Just liberation of H2O. This hydrogen reacts with this one to form H2O gas will be liberated out. Then what is formed? Cl3, C, or all the four bonds, then NO2. This is called as chloropicrene. So it is given in the option chloropicrene, which is a tear gas used in the wars. It is used in the war, which is also called as tear gas. Which is also called as tear gas. So the correct option is option D is the correct option. Next question, question number 23. The reaction C2H5I plus C2H5H11I. This C2H5I, C5H11I reacts with presence of sodium to form this compound. Normal chain is formed. Liberation of NAI. What type of reaction is this? Which is already done. It is nothing but Woods reaction. It is nothing but Woods reaction. Okay. The correct option is option C. Question number 23. We have already done in the previous slide. I showed you Woods reaction. It is a similar type of reaction. Sodium and there was taken chloride. Now it is taken iodide. Whatever the these numbers, but it is combining of two alkyl halide. So it is nothing but Woods reaction. Option C is the correct